Imagine this. A devastating hurricane rips through a coastal community, just leaving behind this trail of destruction. Or maybe a massive earthquake strikes with really no warning, and suddenly every single minute counts in this desperate race against time. In these moments, these really urgent crises, the difference between chaos and control, or between catastrophic loss and inspiring resilience, and often comes down to rapid, informed action. And well, increasingly, that action is being shaped by artificial intelligence. Now, when we talk about artificial intelligence or AI, we're broadly referring to computer systems designed to perform tasks that will typically require human intelligence. Think about really sophisticated data analysis, recognizing intricate patterns in just vast amounts of information, solving complex problems, and making rapid data-driven decisions. It's really about giving machines the ability to, well, think in ways that dramatically augment our own human capabilities. But what's truly fascinating here is that AI isn't just one single thing, is it? It's more like a collection of specialized tools working together.
That's a really crucial distinction. Yeah. Instead of thinking of it as a single brain, AI in this context functions more like a suite of highly developed senses and processing units all working in concert. So, for example, you have machine learning algorithms. They act like the brain's pattern recognition ability, right? Sifting through these immense data sets to predict events and assess risks with incredible speed. Then there's natural language processing, NLP we often call it. That gives AI the ability to sort of understand human communication. So it can sift through news articles, social media posts, even emergency calls to extract vital information.
Extracting meaning from all that noise.
Exactly. And then you've got computer vision, which acts like AI's eyes. It's incredibly adept at rapid analysis of disaster areas, instantly identifying hazards, assessing damage from drone or satellite footage, much faster than a human could. And of course, the physical side, robotics and drones. They extend AI's reach into hazardous environments, which enhances situational awareness, while crucially minimizing risks to first responders during search and rescue.
Right, keeping people safer.
Absolutely. And all of these components, they feed into these AI-powered decision support systems. These help emergency managers track resources, personnel, and basically make incredibly effective choices during a crisis. It's this synergy, this combination that makes AI so potentially powerful here.
That makes perfect sense. Yeah, each element is like a force multiplier, working together to create this comprehensive understanding, this bigger picture. And that's precisely our mission for this deep dive, to explore how artificial intelligence is truly revolutionizing disaster response. We're going to look at its impact across the entire life cycle of emergency management, from predicting natural catastrophes before they even hit, right through to optimizing critical recovery efforts long after the dust has settled. We've analyzed a really rich stack of sources for you, from academic journals to industry reports, all curated just for you, to bring you the real-world benefits, the critical challenges we face, and what the future truly holds for this transformative technology. But this escalating frequency of disasters, it isn't just a grim statistic, is it? It's the urgent backdrop against which AI's capabilities become absolutely critical. We're seeing more and more intense natural disasters every year. So what precisely is driving this immediate, urgent need for new solutions? It's not just the feeling that things are getting worse, right?
No, it's far more than a feeling. If we connect this to the bigger picture, the data, well, it unequivocally shows a dramatic and concerning increase in both the frequency and the severity of natural disasters across the globe. And this surge, it's intrinsically linked to two major global trends. The undeniable impacts of climate change and the accelerating pace of rapid urbanization. The UN Office for Disaster Risk Reduction, UNDRR, they reported a truly staggering figure. Between 2000 and 2019, the number of recorded major natural disasters nearly doubled compared to the previous 2 decades.
Doubled, wow.
Double. Just think about that. Double the major events in the same amount of time. It's quite something. And this isn't just about more events, it's about more intense events. Rising global temperatures, which are a direct consequence of climate change, they're leading to more severe weather patterns across the board. We're witnessing more destructive and frequent hurricanes, longer and more widespread droughts that turn landscapes into, tinderboxes, the rapid melting of polar ice caps contributing to accelerating sea levels.
And warmer oceans fueling bigger storms.
Exactly. Warmer oceans fueling even more frequent and intense storms, widespread coastal flooding, and these devastating wildfires that just tear through communities. Historically, traditional disaster management methods, they've been largely reactive and incredibly resource-heavy. They're simply struggling to keep pace with the escalating scale and speed of these modern crises. Often they're overwhelmed before they can even truly begin to respond effectively.
So it's a perfect storm, you could say, of environmental shifts and increased human vulnerability, making our existing systems just insufficient. And if traditional methods are struggling, that really highlights the absolute criticality of speed and accuracy, doesn't it? When a disaster is imminent, every second truly matters, not just for property, but for human lives.
Precisely. While we can't completely prevent natural disasters from occurring, they are, after all, natural phenomena. Their impact, particularly on human lives and livelihoods, can be vastly reduced through timely and accurate warnings. Consider the stark contrast between two major earthquake events. The 2010 earthquake in Haiti struck with virtually no warning whatsoever. The result was an absolutely devastating loss of life, immense property damage. The suddenness just left no time for preparation.
Just catastrophic.
Utterly. Then, fast forward just 1 year to 2011. The Pan was hit by a truly massive earthquake and subsequent tsunami. But thanks to its highly advanced early warning systems, residents were given precious minutes, sometimes even just a few vital seconds to prepare. Those few minutes allowed for crucial actions like dropping, covering, holding on, or evacuating to higher ground. And that significantly reduced casualties, minimized the overall impact. It literally bought time for survival.
Seconds making the difference between life and death.
Exactly. This stark comparison underscores a fundamental goal for integrating AI in disaster management: to enable faster, more precise forecasting, prediction, and risk assessment. When we have the ability to anticipate and predict with greater accuracy, it translates directly into saving lives, preserving critical resources, and giving communities a fighting chance to prepare rather than merely react. It's about shifting from a reactive posture to a proactive, even preventative one, giving people the lead time they desperately need to make life-saving decisions and mitigating potential harm before it even fully materializes.
That proactive shift is truly a game changer. So, okay, what does this all mean for how we actually manage these crises day to day or moment to moment? It sounds like AI isn't just for one part, but it's integrated across the entire life cycle, right?
Yeah.
From before a disaster even hits to long after. It's not just a single application, but a comprehensive tool used in multiple phases: prediction, mitigation, response, and recovery.
Exactly right. Traditionally, disaster management is often viewed in those four distinct phases: mitigation, preparedness, response, and recovery. And AI is now being woven into the very fabric of each one, fundamentally altering how we approach each stage.
Okay, let's start at the very beginning of that cycle then. Prediction and risk mapping. This is about seeing trouble before it even arrives. The core concept here, as I understand it, is that AI algorithms are powerful enough to analyze truly vast data sets, allowing them to detect patterns that forecast natural disasters with significantly higher accuracy and speed than we ever thought possible.
Indeed, machine learning models are really at the heart of this predictive capability. They ingest and analyze historical data, real-time data, from an incredibly diverse range of sources. We're talking about everything from ground sensors, satellite imagery, social media feeds, yes, even social media, to meteorological forecasts, seismic activity records, complex climate patterns, hydrological data. The list goes on. By processing all this information, often far more than any human team could possibly process in a reasonable time frame, AI can identify subtle precursors, maybe anomalous readings or emerging trends that might otherwise go unnoticed. But these subtle signs can be crucial indicators of an impending event.
That capability to analyze these massive diverse data sets, it really does sound like a kind of superpower. But practically speaking, what does that look like on the ground? And are there any maybe surprising data sources AI is now leveraging for prediction that we might not expect? Like you mentioned, social media.
That's a great question. Yeah, let's delve into some specific examples. For earthquake prediction, the challenge isn't just predicting the initial quake, but also the often devastating aftershocks that follow. DeepMind's AI algorithms, for instance, showed significant promise in Japan back in 2021. They demonstrated an ability to predict aftershocks more precisely by analyzing seismic data in, well, unprecedented ways. This gave first responders crucial, really granular information for planning their follow-up actions and limiting further damage to already compromised areas.
So not just the big one, but the ones that come after too.
Exactly. And it's not just DeepMind. Stanford University is pushing the boundaries, using AI to try and predict tremors mere seconds before they occur, providing that vital instantaneous window for people to take cover. Google AI and Harvard University have also developed sophisticated models specifically for predicting aftershocks, really refining the science of seismic forecasting. Then, when it comes to flood forecasting, the scale of impact can be just immense. Google's AI flood forecasting system, which has been successfully deployed in parts of India and Bangladesh since 2018, is a great example. It analyzes intricate hydrological and meteorological data to deliver early warnings that can literally mean the difference between life and death. This system has proven invaluable, providing prompt notifications often days in advance.
Days, not just hours.
Days, yes, enabling timely evacuations and allowing authorities to organize their responses efficiently before floodwaters even rise. Imagine the logistics of evacuating hundreds of thousands without that kind of lead time. And NASA's Global Flood Monitoring System also integrates AI with satellite data to assess flood risks on a global scale, essentially watching river basins and floodplains from space.
That shift from seconds or minutes, like with earthquakes, to days for flood warnings. That isn't just an incremental improvement. It fundamentally redefines how communities can prepare. It's moving from a desperate scramble to a more strategic, organized evacuation. That changes the entire human experience of an impending disaster. What about larger, more widespread events like hurricanes, where the paths are so notoriously unpredictable?
You've hit on a key point there. The precision is the real game changer. For hurricane path prediction, IBM's Watson AI and NOAA, the National Oceanic and Atmospheric Administration in the U.S., they're using machine learning. They're predicting hurricane paths and intensities with vastly improved accuracy compared to older methods. And this precision is vital for reducing unnecessary evacuations. Think about the huge economic cost and social disruption of evacuating millions unnecessarily. So better predictions save significant resources while still ensuring that those truly in harm's way receive timely and accurate warnings. It's about optimizing safety without incurring undue societal burden. And beyond water and ground shaking, AI is proving critical for wildfire detection, which is sadly a rapidly growing threat in many parts of the world. AI models combined with satellite imagery and sensor data allowed for the remarkably early detection of wildfires in California back in 2020, often before they became these unmanageable infernos. This enabled swift fire service response, preventing more extensive damage to property and lives.
Catching them when they're small.
Precisely. Even more advanced now, Alert California and Yellfire are actively using AI to recognize smoke from an extensive network of over 1,000 cameras, 1,050 cameras distributed across California's most vulnerable regions. This system is proving especially useful for monitoring remote areas and identifying fires potentially before they're even reported through 911 calls, often when there's still just, wisps of smoke. During its first 2 months of operation alone, this AI system correctly identified 77 fires. Many of those likely would have otherwise gone undetected until they were much larger and more destructive. It's like having thousands of vigilant eyes constantly scanning the landscape 204/7.
So AI isn't just about predicting if something will happen, but also where and how severely. That leads us naturally to risk mapping. How does AI contribute to understanding vulnerability and proactively maybe fortifying communities before anything happens?
Yeah, AI-powered geospatial analysis plays a key role here, creating incredibly detailed risk maps. It identifies high-risk zones, earthquake-prone regions, floodplains with a level of granularity that was previously impossible. This helps communities and urban planners prioritize their preparedness efforts much more effectively. For example, AI can assess which specific neighborhoods are most at risk for flooding during a major storm. It does this by analyzing historical flood data, elevation data, drainage infrastructure, even things like the type of building materials used in an area. This allows cities to focus preventive measures where they'll have the most impact, whether that's building reinforced levees, improving drainage systems, or perhaps even identifying vulnerable populations that might need preemptive relocation support. It essentially gives communities a data-driven blueprint for where to invest their mitigation efforts most effectively, moving beyond broad strokes to really hyper-targeted interventions.
Okay, moving from predicting to preventing, AI is also playing a significant role in mitigation. This involves actions taken well in advance to minimize potential impacts. This isn't just about reacting once the disaster hits, but about building a more resilient future, right? It's about the proactive measures that save lives and, frankly, billions of dollars down the line.
Absolutely. This phase is where AI really helps us anticipate vulnerabilities in critical infrastructure and informs urban planning decisions that can reduce future damage significantly. Deloitte Research, for example, found that AI applications like predictive maintenance and something called digital twins could prevent an astonishing 15% of projected natural disaster losses to critical infrastructure globally. We're talking power grids, water systems, transportation networks. This amounts to an estimated $70 billion in savings worldwide by 2050.
$70 billion. That's a massive financial impact, not even mentioning the avoided disruption and human suffering. Can you explain what digital twins are in this context? It sounds a little bit like something out of a sci-fi movie.
It does sound futuristic, doesn't it? But it's very real and incredibly powerful. A digital twin is essentially a virtual, real-time replica of a physical object or a system or even an entire city. It's constantly updated with data from its physical counterpart through sensors, satellite feeds, other inputs. So in disaster management, this means creating digital replicas of entire environments or critical infrastructure. For example, there's a resilience technology company called One Concern. They combine AI with digital twins in Japan to visualize possible impacts of disasters, say an earthquake or a typhoon on critical infrastructure like power grids, roads, airports.
So they can run what-if scenarios.
Exactly. Planners can run simulations on these digital twins to see how systems might fail under various disaster scenarios. They can then use that insight to plan for resilience, identify weak points in the system, and even test mitigation strategies in a safe virtual environment before they implement them in the real world. Similarly, the Destin project in Europe is building digital twins of entire Earth systems using machine learning. The goal there is to better understand the long-term effects of climate change and extreme weather events, allowing for proactive, really large-scale planning.
That sounds incredibly powerful for proactive planning. What other examples do we have for mitigation where AI is helping build smarter defenses?
Well, AI tools are revolutionizing how we plan for things like rising sea levels, for instance. They can simulate how different sea level rise projections might affect coastal cities, allowing governments to prioritize reinforced flood defenses with data-driven precision. The city of Amsterdam, which is, a master of water management historically, already uses AI to manage its intricate flood defenses. They employ these data-driven models to predict when and where to deploy flood barriers based on real-time weather and water level data. It's a dynamic defense system, not a static one.
Adapting in real time.
Precisely.
Yeah.
Furthermore, AI-powered building simulations can identify weaknesses in existing infrastructure, like bridges or older buildings. They can recommend specific, targeted improvements to reduce the risk of collapse during events like earthquakes or high winds. It's all about building smarter and stronger before a disaster even looms, fundamentally shifting our approach from repair after damage to prevent before damage.
Okay, so we've predicted, we've mitigated. But inevitably, disasters still strike. Now it's all about the immediate aftermath, the chaos, the urgent need for information, and that race to save lives. AI steps into the response phase, which is critical for supporting emergency operations and making accurate predictions about immediate needs by analyzing huge dynamic data sets. This is where AI truly improves speed, coordination, and accuracy when lives are literally on the line.
You've perfectly captured the urgency. Yes, during the response phase, AI really shines in providing real-time data analysis and situational awareness. It analyzes enormous volumes of diverse data, frantic news articles, millions of social media posts filtering through, emergency calls flooding in, live feeds from sensors, satellites, drones, just a torrent of information. This constant incoming stream is processed at speeds no human team could possibly match, providing a comprehensive, up-to-the-minute picture of the situation on the ground. This real-time intelligence is absolutely essential. It enables informed, quick decision-making for emergency services, helping them triage needs and deploy resources effectively.
And how does AI assist with search and rescue operations? These are often the most immediate, dangerous, and frankly emotionally charged parts of any disaster response.
For search and rescue, Sarah and robotics, AI-powered drones proved invaluable during Hurricane Harvey in Texas back in 2017. Instead of sending human teams into precarious, flooded areas, drones surveyed affected areas rapidly. They helped first responders find survivors and assess structural damage in just a fraction of the time it would have taken using conventional methods. Imagine trying to cover hundreds of square miles on foot or by boat in those conditions.
Impossible, really.
Pretty much. The Red Cross, for instance, now employs drones and AI vision tools to assess post-disaster damage in hours instead of weeks. That's a huge leap in efficiency, allowing for much quicker resource deployment to the hardest hit areas. These drones can navigate challenging, often hazardous environments, think unstable buildings, dense rubble to locate survivors. They do this by analyzing visual data, looking for heat signatures, or even detecting subtle signs of distress. This was vividly demonstrated during the Mexico City earthquake in 2017. They minimize risk to human responders while maximizing the speed of finding those in need. It really transforms how we approach that critical golden hour of rescue.
Beyond finding people, there's the immense logistical challenge of getting aid where it's needed most, especially when infrastructure is damaged and roads might be impassable. How does AI help with resource allocation and logistics in such chaotic environments?
AI systems are incredibly adept at optimizing the allocation of emergency supplies, manpower, equipment, all the crucial resources. They evaluate dynamic demand and logistics in real time, considering factors like road closures, population density, reports of immediate needs, ensuring resources reach crucial regions promptly and effectively. After the devastating 2010 Haiti earthquake, for example, AI was used to create optimized delivery routes for aid workers. It helped them navigate the damaged infrastructure to get life-saving supplies where they were most needed, even reaching isolated communities cut off by debris.
Finding paths through the rubble,
Yeah,
essentially.
exactly. We even saw AI's impact during the unprecedented COVID-19 pandemic. AI-driven outbreak tracking systems helped hospitals allocate critical resources like ventilators, hospital beds, and PPE based on real-time infection trends and regional needs. This helped prevent supply chain collapse in many areas. It's like having a master strategist constantly recalculating the optimal chess moves on a global scale during a crisis.
And what about communication, both with the public and managing the sheer flood of incoming information during a crisis? That always seems like a major bottleneck.
That's where communication and public safety truly benefit from AI. Natural language processing, or NLP, tools are used to monitor diverse communication channels, social media, news reports, emergency calls. They can detect early warning signals of developing situations, identify and even help counter misinformation spreading rapidly online, which can cause panic and seriously hinder response efforts or pinpoint urgent needs being expressed by affected populations. This allows emergency services to prioritize incoming calls, making sure the most critical situations are addressed first.
Filtering the signal from the noise.
Precisely. And AI chatbots, like the Red Cross's Clara or the World Health Organization's WhatsApp bot for COVID-19 updates, they assist the public directly. They provide crucial information like evacuation routes, shelter locations, essential resources. This offers round-the-clock, multilingual support, which significantly reduces the burden on human operators who are already stretched thin. AI can also help manage the overwhelming volume of 911 calls during a major incident. It can parse information from similar incoming reports, group them, and even filter background noise to help dispatchers hear faint mayday calls amid chaotic scenarios. It's about cutting through that noise to find the critical signal.
Finally, after the immediate crisis passes, we have the crucial phase of recovery, rebuilding stronger and smarter. AI isn't just about the immediate crisis response, but also about the long game of getting communities back on their feet and, importantly, making them more resilient for future events. It's the ultimate long-term investment, really.
Exactly. AI extends its benefits far beyond the immediate response to support long-term recovery and enhance resilience against future disasters. One key application here is rapid and precise damage assessment. AI systems rapidly evaluate satellite photos and drone footage using machine learning and computer vision to assess damage following a disaster. This isn't just about counting damaged buildings. It helps prioritize regions for rescue and recovery activities, accurately gauge the degree of destruction at a very granular level, and estimate the financial impact, all within hours or days instead of the weeks or months manual assessments used to take. This speed is absolutely critical for securing aid and beginning the rebuilding process efficiently.
That's a huge improvement over manual assessments that could take weeks, even months. How does AI help with the actual rebuilding process itself, especially when we're talking about complex infrastructure like power grids or transportation networks?
For infrastructure rebuilding, AI helps governments model various recovery scenarios. It helps figure out how best to rebuild utilities or transport networks in the most efficient and crucially resilient way possible. After Hurricane Maria devastated Puerto Rico in 2017, for instance, AI was used to simulate and prioritize power grid repair scenarios. It identified the most critical segments to repair first to restore power to the largest number of people quickly. It identified impassable roads and bridges that needed clearing, rerouted emergency supply routes.
Wow, really detailed planning.
Very detailed. And it even integrated health, income, and demographic data to guide recovery efforts specifically in underserved communities. This ensured a more equitable and efficient rebuild that often targeted areas that might have been historically neglected in past recovery efforts. So it goes beyond just fixing what's broken. It's about strategic, equitable reengineering for the future. Beyond that specific infrastructure, post-disaster recovery modeling uses AI to simulate entire recovery scenarios over extended periods. This offers insights into best practices for reestablishing services, rebuilding infrastructure effectively, and mitigating the long-term negative social and economic effects that can linger long after a disaster fades from the headlines. This allows for a much more strategic and informed approach to the complex, often multi-year process of recovery, helping planners visualize the potential ripple effects of their decisions.
And what about the human element in recovery? Supporting individuals and communities. It sounds like AI could potentially be quite cold or impersonal in that sensitive area.
Actually, on the contrary, AI can contribute significantly to community support. It can help identify vulnerable populations, the elderly, those with disabilities, low-income families, to ensure they receive necessary health and social services without delay during the recovery phase. It can also predict the economic impacts of disasters on specific industries or local businesses. This is crucial for planning targeted business interventions and helping restore livelihoods more quickly. Furthermore, and perhaps surprisingly to some, first responders have even reported that AI could complete up to 90% of the administrative documentation required after an incident.
90%. That frees up a lot of time.
A huge amount. This means AI takes on the tedious, time-consuming paperwork, allowing human responders to focus far more on direct patient care, community engagement, providing emotional support, things humans do best, and they can provide the crucial finishing touches to reports later. This human-in-the-loop approach means AI handles the data entry, freeing up human empathy and expertise for where it's truly needed most, supporting people through a difficult time.
Okay, it really sounds like AI is doing a lot, from predicting to rebuilding, essentially transforming our entire relationship with disasters. But stepping back, what are the big picture advantages here? What are the truly tangible benefits of integrating AI into emergency management, especially when you consider the sheer scale of the challenges we face?
Well, if we synthesize the benefits across all these phases we've discussed, it becomes clear that AI is fundamentally transforming how governments, first responders, and humanitarian agencies manage disasters. It leads to smarter, faster, and demonstrably safer operations. First and foremost, AI enables much faster decision-making. By processing these massive datasets in real time, it allows for quicker responses to evolving threats and provides actionable insights in moments of crisis, which is absolutely paramount when seconds count. This speed also leads directly to dramatically improved accuracy. Predictive models and sophisticated data analytics significantly reduce the potential for human error and enhance overall situational awareness. This ensures that critical decisions are based on the most precise, up-to-date information available. And linked closely to this is optimized resource use. AI helps allocate emergency resources, supplies, personnel, vehicles exactly where they are needed most and when they are needed most. It minimizes waste and maximizes impact in a highly efficient manner.
And what about the people on the front lines, the brave individuals who are putting their lives at risk during these events?
For first responders, there's a critical benefit: increased responder safety. Technologies like drones and robotics, combined with AI risk analysis, allow for operations in hazardous conditions without putting humans directly in harm's way as often. It reduces human exposure to dangerous environments and disaster zones. This saves lives not just among the affected population, but also among those responding to the crisis. And on the financial side, we see truly significant cost reduction. Automation, smarter planning based on predictive insights, they all minimize waste and lower overall emergency management costs. Remember that Deloitte projection we mentioned earlier?
$170 billion savings.
Exactly. It estimates AI could lead to $70 billion in savings worldwide by 2050 just on infrastructure losses alone from natural disasters. That's a staggering amount that can potentially be reinvested in further resilience measures or other community needs. Finally, AI contributes to better public communication. AI chatbots and natural language processing tools ensure timely, multilingual, and consistent messaging to the public. This is crucial for maintaining calm, disseminating accurate information, and guiding people effectively during a crisis. And looking at the broader context, AI-driven strategies also contribute directly to ESG integration that's environmental, social, and governance principles. So AI helps with environmental sustainability through optimized resource use and potential emissions reduction in response logistics. It promotes social equity by helping ensure vulnerable populations receive timely and equitable support. And it enhances enhances governance and transparency by providing robust, data-driven insights for policy and decision-making. It's truly a holistic improvement, potentially touching every facet of disaster management.
This technology is clearly powerful, with so many potential benefits.
Yep.
But like with any really advanced tool, there has to be significant hurdles and complex considerations that come with deploying it, right? What's fascinating here, listening to you, is how much it seems to come down to something as fundamental as trust in the data, trust in the algorithms, and ultimately trust from the public and the responders themselves.
That's a truly critical point, yes. While AI offers immense potential, there are a number of serious challenges and vulnerabilities that absolutely must be addressed to ensure its effective, fair, and safe deployment. The first major hurdle is often data quality and availability. AI models, as we've said, rely on enormous volumes of real-time, high-quality, clean data to produce reliable forecasts and evaluations. However, many disaster-prone areas, particularly in developing regions, simply lack comprehensive or reliable data sets. Even within well-resourced countries like the U.S., FEMA's data strategy highlights issues like outdated references and non-standard surveys in certain regions. If the data coming from sensors, satellites, or even social media is inadequate, delayed, or just plain erroneous, it can severely hamper AI's ability to provide accurate and timely warnings. It can lead to potentially dangerous misinterpretations or missed signals. Garbage in, garbage out, as they say. Building on that data issue, we face the pervasive challenge of algorithmic bias. If AI systems are trained on data sets that reflect historical, societal inequalities or contain incomplete information about certain groups, they can inadvertently perpetuate or even amplify those biases. This can lead to inaccurate risk assessments that potentially result in uneven or insufficient response efforts, especially affecting low-income or minority neighborhoods. Imagine a scenario where, say, important infrastructural data is missing from historical records related to marginalized communities. An AI trained on that skewed data might under-prioritize those vulnerable communities in resource allocation, reinforcing pre-existing disparities and leading to really serious ethical issues and disproportionate harm. Ensuring data equity is absolutely paramount.
That's a really significant concern, especially when you're dealing with life-saving resources. What about the practicalities? Deploying these sophisticated systems in the very environments they are designed to help places often devastated by the disaster itself, where infrastructure might be gone.
That brings us right to technical infrastructure dependency. AI-based systems rely heavily on dependable power sources, robust cloud computing resources, and uninterrupted internet access. The fundamental problem is that this very infrastructure can be severely compromised or completely destroyed in a disaster zone. This makes it incredibly difficult, sometimes impossible, to use these advanced AI techniques precisely when they are most needed. And many disaster-prone areas, especially in developing countries or remote regions, simply lack the strong technological infrastructure required to support these advanced AI systems in the first place. This creates a kind of digital divide in disaster resilience. Then there's the challenge of interoperability and integration. New AI systems need to seamlessly interface and interact with existing, often much older, emergency response frameworks, and they need to work across multiple agencies: police, fire, medical, public works, which often operate in silos. Getting these systems to talk to each other can be technically difficult, time-consuming, and expensive. If these disparate systems can't communicate effectively, critical information might not be shared, leading to fragmented responses or severe delays in aid delivery. Imagine a fire department's AI system identifying a hazard but being unable to communicate that instantly to a police department system during a multi-agency response. It undermines the very coordination AI is supposed to enhance.
And what about the risk of malicious actors? People deliberately trying to exploit these advanced systems during a crisis. The absolute last thing you need is a cyber attack when lives are hanging in the balance.
Indeed. Security flaws and cyber attacks are a major concern. As AI tools become more central to disaster management, controlling things like warning systems, resource allocation databases, communication networks, they become increasingly appealing targets for hackers. A successful attack could impair forecasts, maybe result in critical data breaches, leaking sensitive information, or interfere with response operations at critical moments. This could potentially lead to widespread panic or even directly exacerbate a crisis. Law enforcement, for example, worries about the potential for deepfakes being used to spread false information rapidly or false accusations designed to divert scarce resources. And there's malicious abuse like swatting, that dangerous act of making a false emergency report, which could be weaponized in a disaster scenario to deliberately overwhelm already strained emergency services. This also ties directly into crucial privacy and ethical concerns. Using AI in disaster response often entails collecting and handling very sensitive personal information from impacted communities, things like health data, current location, family details. This requires incredibly robust data governance and privacy safeguards, like strict compliance with regulations such as GDPR in Europe to protect that vulnerable data from exploitation or misuse. There's also the complex issue of unclear legal accountability for AI decisions. Who is responsible if an AI makes a critical error that leads to adverse outcomes? Is it the developer,
Exactly.
the user, the agency? This legal gray area needs much clearer definition for widespread adoption and trust.
All these technical and ethical challenges, they really feed into that bigger issue you mentioned earlier, trust in AI and public acceptance. If people, both the public relying on the warnings and the responders using the tools, don't trust the technology, they simply won't use it effectively, or they might not follow its guidance when it matters most. It seems like a fundamental hurdle.
Precisely. Both the public and frontline responders, like, say, experienced weather forecasters and government agencies, may hesitate to fully rely on AI due to a lack of transparency into how AI decisions are actually made. This black box nature, where the reasoning isn't clear, can be a significant psychological barrier. Furthermore, false alarms generated by AI systems, even if they're statistically rare, can cause unnecessary panic, strain already stretched resources, and crucially, rapidly erode public trust. This makes people less likely to heed future warnings, even critical ones. Conversely, false negatives where an AI system fails to predict a disaster or misses a critical need can lead to catastrophic losses and completely shatter confidence in the technology. And we've seen how AI chatbots in other contexts can sometimes generate hallucinations, these convincing but completely unreliable or even fabricated answers. In a crisis where accurate information is paramount, that could be dangerously misleading. Another very practical challenge is the absence of AI expertise and training, or what we sometimes call adoption challenges. Many government organizations and emergency response agencies simply lack the internal technical know-how, the necessary computing hardware, or the robust network capabilities to effectively create, use, or even interpret sophisticated AI models. Smaller counties or municipalities, for instance, might struggle to actually use FEMA's advanced AI-generated damage maps if they don't have modern data infrastructure or personnel trained to interpret complex geospatial data. There's also often a cultural reluctance among some planners and first responders to adopt AI over traditional manual methods simply because that's how we've always done it. That's a powerful inertia that any new technology must overcome.
And all this sophisticated technology, it certainly isn't cheap, is it? I imagine the cost of implementation must be a significant barrier, especially for nations or communities already grappling with frequent disasters and limited budgets.
You're absolutely right. The upfront and ongoing costs of cutting-edge AI technology can be prohibitively expensive. This is especially true for developing nations, which are often disproportionately affected by climate-related disasters, yet have the fewest resources. Gaining the substantial capital investment and sustained political support needed for AI infrastructure, advanced hardware, specialized training, and ongoing research and development is a major roadblock to its mainstream, equitable implementation worldwide. Finally, there are considerable regulatory and policy obstacles. Existing laws and regulations often need to be drafted or significantly modified to explicitly account for AI's rapidly evolving role in emergencies. This needs to cover everything from secure data exchange protocols and ethical usage guidelines to clear interagency coordination frameworks. Without clear, comprehensive legal frameworks and standardized policies, widespread, consistent adoption across different jurisdictions becomes incredibly difficult. All these issues combine to make AI deployment complex, but as we'll discuss, these are surmountable challenges if they're addressed thoughtfully and proactively.
Okay, it's definitely clear AI isn't just some kind of magic silver bullet. It's a really powerful tool, but one that requires careful, thoughtful implementation and a very strategic approach. So if we connect this back to the bigger picture, how do we make sure AI fulfills its immense promise safely and effectively? How do we address all those challenges we just talked about? How do we actually build that crucial trust?
That's the crucial question, isn't it? And it really defines the path forward. The solution involves a multi-pronged approach. It focuses both on relentlessly enhancing the AI capabilities themselves and, perhaps even more importantly, on consciously building and maintaining profound trust with users and the public. To start with building trust and responsible use, transparency is absolutely paramount. We need transparency and explainable AI, XAI. This means clearly explaining how these AI tools work, where their data comes from, and ensuring that their outputs are easy for responders to understand and verify. It's about moving away from those opaque black box models. Developers should provide comprehensive documentation, things like metadata, datasheets, and model cards that detail the data quality, potential biases, ethical considerations, and, critically, how the model actually functions. For instance, if a user wants to understand why an AI system provided a specific earthquake detection alert, a local explanation focused on that event might suffice. But if they need to understand why that same system repeatedly fails in a certain region, then a more global explanation of its training data limitations and assumptions would have greater value. It's about opening the hood, so to speak, making it understandable. And crucially, there must always be human oversight. AI should support human judgment, enhance it, not replace it entirely. The final decisions, especially those involving life or death consequences, must remain with trained human personnel who understand the local context, can assess nuances AI might miss, and importantly, can override the algorithms when needed. This approach, often called human in the loop, is essential for safety, accountability, and maintaining public confidence. It's about empowering our human responders with better tools, not replacing their critical judgment.
So it's about creating a genuine collaboration between humans and machines, where each brings their unique strengths to the table. That makes perfect sense.
Exactly. And that collaboration should extend to the very design process itself through inclusive design, involving diverse communities, local leaders, stakeholders, and importantly, frontline responders in AI development from the earliest stages is vital. This helps ensure that the systems are designed to serve everyone fairly and equitably. It directly addresses the issue of algorithmic bias from the ground up, making sure systems are robust, relevant, and trusted by all the populations they are meant to assist. Parallel to this design work, we need significant investment in training and literacy. It's critical to inform emergency response teams and local populations about AI's advantages and, just as importantly, its limitations. Giving responders the skills to use these tools confidently and responsibly will ensure efficient use and proper interpretation of AI recommendations, avoiding either over-reliance or misunderstanding. Complementing this is effective public engagement, helping communities understand how AI supports their safety and response efforts during a crisis, explaining what it does and what it doesn't do, will build trust and encourage cooperation with AI-enabled systems like those early warning chatbots we discussed. And just like any critical system, whether it's a bridge or a power grid, there must be regular testing and auditing. AI models should be continuously tested and assessed for correctness, dependability, and fairness, especially as new data comes in or environmental conditions change over time. This should ideally include public reporting of findings, which further fosters transparency and accountability. This ongoing assessment ensures the models can adapt to new kinds of disasters or evolving environmental changes, remaining effective and reliable over the long term.
Okay, so building trust is fundamental. Beyond that, what are the key technical and strategic ways we can actually enhance AI's effectiveness in this field and truly push the boundaries of what's possible?
For key strategies for enhancement, we definitely need vastly improved data integration and real-time analysis. This means integrating real-time data from a multitude of diverse sources: satellites, ground sensors, smart city infrastructure, social media feeds, government databases, weather models, to get a truly comprehensive picture for predictive abilities and dynamic situational awareness. Developing robust technologies that provide easy data collection and instantaneous real-time analysis is absolutely vital for enabling immediate, informed action. We also need much stronger government and AI developer collaboration. Creating forums for cooperative innovation, standardizing data formats across different agencies and even nations, and facilitating seamless information exchange will maximize the creation and deployment of powerful AI-powered disaster response technologies. This definitely includes fostering robust public-private partnerships, leveraging the agility and innovation of tech companies with the reach, resources, and regulatory power of governments. Enhancing better disaster simulation and modeling is also key. AI-driven simulations can realistically mimic various disaster scenarios, from tsunamis hitting complex coastlines to wildfires spreading across different types of terrain under varying weather conditions. They can also explore different potential recovery paths. This allows responders and planners to try several tactics and test resource allocation strategies before a real disaster hits, helping with contingency planning and optimizing response protocols in a safe, low-stakes virtual environment. Furthermore, investing in increasing AI system resilience is absolutely crucial. In times of crisis, when traditional infrastructure like power and connectivity may be compromised, AI systems need to be resilient enough to continue operating effectively. This entails making investments in fail-safe systems, developing offline AI capabilities that can function without constant connection, and promoting edge computing where data is processed locally at the source, like on a drone or sensor itself, rather than relying solely on cloud connections. This ensures functionality even when central internet access is restricted or completely down. We must also commit to investing in next-generation AI technology, supporting fundamental advances in areas like computer vision, reinforcement learning, where AI learns through trial and error, and natural language processing will make AI even more useful and intuitive in disaster management. This could lead to more precise analysis, more natural human-AI interfaces, and extracting even more actionable insights from unstructured data like text reports or images. The bigger vision also includes developing global AI networks. Imagine creating interconnected systems where countries and international organizations can share real-time data and insights for multi-country disaster prediction and response. Think about tracking a massive hurricane across multiple oceans, or coordinating a complex humanitarian response for a multinational refugee crisis triggered by a disaster. This kind of collaboration would greatly enhance global resilience and coordinated international efforts. And looking even further ahead, AI models will play a critical role in AI in climate change mitigation. Beyond just responding to current disasters, they will be increasingly used in creating long-term strategic plans to lessen future disaster effects. This involves locating susceptible areas with greater precision, optimizing resource allocation for climate adaptation projects, and enhancing overall adaptation efforts for a rapidly changing planet. And finally, to tie all this together effectively, we absolutely need harmonized terminologies and policies, adopting common language around disaster risk and AI, and establishing clear national and regional policies like the U.S. Executive Order 13960 on promoting trustworthy AI in government, or the comprehensive EU AI Act, along with global standards, will foster clearer communication, enable consistent ethical deployment, and ensure seamless interoperability across diverse disciplines and international borders.
Wow, what a deep dive. We've really seen how AI is truly transforming every single stage of disaster management, offering us unprecedented speed, accuracy, and efficiency. It really is a potential game changer that helps us move from simply reacting after the fact to proactively preparing and, hopefully, more effectively recovering. It fundamentally changes the equation when disaster strikes. It almost feels like we're equipping ourselves with a new kind of superpower, albeit one we need to learn to wield wisely.
Indeed, AI is revolutionizing how we predict natural catastrophes, streamline those critical immediate response efforts, and optimize long-term recovery. It's really about leveraging these AI-driven prediction models, the real-time data processing, the sophisticated automation to potentially save more lives and significantly reduce financial losses. But it is a careful balance, isn't it? A balance between pushing technological advancement forward and ensuring ethical, transparent deployment while always remembering the human element. At its core, AI is designed to assist humans to augment our capabilities, not to replace the essential qualities of empathy, critical thinking, and decisive on-the-ground action that are just irreplaceable in any crisis. It helps us make faster, more informed decisions, certainly, but the human element remains absolutely paramount, guiding the technology with wisdom, experience, and compassion.
So thinking about that future, as AI continues to learn and evolve at this incredible pace, how might our collective definition of preparedness fundamentally shift in the decades to come? Could we move entirely beyond reactive measures to a truly proactive, data-driven societal resilience guided by these intelligent systems?